In the last part we studied about the troposphere. Now it is a time to study the stratosphere. And regarding the stratosphere, there is a contradicting opinion regarding the height. Some scientists say it is from 25 to 30 kilometer. Some scientists say it is at the height of 80 kilometer. But on an average, the upper limit of the stratosphere is taken to be 50 kilometer. So if you see the diagram, the upper limit is taken as 50 kilometer. So suppose if this is the stratosphere and it is at the height of 50 kilometer. Okay. Now again there is a contrasting opinion regarding the change or no change of temperature with increasing height. Few scientists believe that there is no change and others hold that temperature gradually rises upward and it becomes 0 degree centigrade at the height of 50 kilometer. Upper layer is the stratopause. There is a circulation of feeble winds and cirrus cloud in the lower stratosphere, and there is ozone layer 15 to 30 kilometer up to 80 kilometer. And the lower portion of the stratosphere is called ozonosphere, which is 15 to 35 and the upper limit is 55. And ozone is faintly blue irritating gas with the pungent odor. And the ozone destruction is caused by the halogenated gas caused chlorofluorocarbon, CFC in short, halogens and nitrogen oxide. So make a note, the destruction of the ozone is caused by halogenated gases. Okay, that is halogenated gases caused chlorofluorocarbon, halogens and the nitrogen oxide. So this may be our question for the exam. Now next comes the mesosphere. It extends from 50 to 80. So in the diagram already we put 50. So above that it will be till 80 kilometer in height, something like this. Okay, so totally it will be 80 from the Earth's surface. And the temperature decreases with increase in temperature and the rise in temperature stops at stratopause. Okay, uppermost 80 kilometer temperature is 80 degrees centigrade, that is minus 80 degrees centigrade, and this limit is mesopause, above which the temperature increases with increasing height. Now next comes the thermosphere, the part beyond mesopause where the temperature increases rapidly with increasing height. So after this we have a thermosphere, mesosphere, then thermosphere. In the temperature increases rapidly with increase in the height and the temperature at upper limit becomes 1700 degree centigrade. And this thermosphere is again divided into two layers. One is the ionosphere and next is the exosphere. Okay, what is the ionosphere? The ionosphere layer is nothing but it extends from the 80 to 640 kilometer. It consists of the ions and there are number of ionic layer in this sphere, that is D layer, E layer, F layer and the G layer. So ionosphere itself consists of so many layers. D layer is nothing but 60 to 99 kilometer. It reflects the signal of the low frequency radio waves but observes the signals of the medium and the high frequency waves. So make a note, D layer reflects the low frequency radio waves but it observes the medium and the high frequency waves. And this layer, it's very peculiar, it disappears with the sunset because it is associated with the solar radiation. Make a note, D layer disappears with the sunset. Clear? Because it is associated with the solar radiation. Next comes the E layer. It extends from 99 to 1130 kilometer. It is also known as the Kenley heaviside layer. This layers reflect back medium and high frequency radio waves back to the earth. Make a note, D layer reflect only the lower frequency, medium and the higher frequencies are observed, but E layer reflect medium and high frequency radio waves back to the earth. And this layer is produced due to interaction of solar UV photons with nitrogen, thus disappears with the sunset. So again D layer, how it disappears with the sunset, E layer also disappears with the sunset. Then sporadic E layer is associated with the high velocity wind and is created under special circumstance. This reflects very high frequency radio waves. Now E2 layer found at 150 kilometer and is produced due reaction of UV solar photon with the oxygen and disappears at the night. So clear. Now coming to the F layer, which consists of F1 and F2, 150 to 380 kilometer, and they are collectively called Appleton layer. So make a note, F layer is also called as a Appleton layer. They reflect high and the medium frequency radio back to the earth. Next comes the G layer, and it is from 400 kilometer and above. Most probably persists day and night, but it is not detectable. Most probably persist day and night, but is not detectable. Is it clear? Okay, fine. Next comes the exosphere. The uppermost layer, density extremely low, and the atmosphere resembles a nebula because of its highly rarefied, and the temperature becomes 5568 degree at its outer limit. Now let us study about the chemical composition of the atmosphere. Based on the chemical composition, atmosphere is divided into two broad zones, that is the homosphere and the heterosphere. Homosphere, lower portion of the atmosphere extends up to 90 km from the sea level, is called as the homosphere, and the main constituents gases are oxygen and nitrogen, and the concentration of the atmosphere carbon dioxide at the beginning of the industrial revolution, that is around 1860 AD, was fixed at 280 to 290 ppm parts per million by volume, but now increased to 350 to 360 parts per million, that is during 1988 AD. The proportion of ozone is rapidly decreasing. On the basis of the thermal condition, the homosphere has been divided into three layers: troposphere, stratosphere, and the mesosphere. So it is another way of classification where we say it is a homogeneous and the heterogeneous layer, isn't it? Homogeneous on the basis of the chemical composition. Homogeneous and the heterogeneous. Homogeneous consists of troposphere, stratosphere, and mesosphere, like we saw before, and the heterosphere extends from 90 to 10,000 kilometer, and the four distinct layers of the gas in this sphere are molecular nitrogen layer 90 to 200, atomic oxygen layer 200 to 1100, helium layer up to 3500 kilometer, and atomic hydrogen layer up to outermost limit. So just in the order you remember: molecular nitrogen layer, then molecular oxygen layer, then helium layer, then atomic hydrogen layer. So nitrogen, oxygen, okay, helium, hydrogen. So in this order you can remember from the earth surface to the higher altitude. And now the elements of weather and climate. Weather, in short, it is a short-term variation of the atmospheric condition and is highly variable. Climate is the aggregate weather conditions of any region in long perspective. G.F. Taylor defined climate is the integration of the weather, and weather is the differentiation of the climate. So the temperature, pressure, humidity, precipitation, cloudiness are the elements of the weather and climate. Okay, so in this part we have learned so many data, so it is better to listen again and again so that you can memorize the data, the like extent of the particular layer in the atmosphere, to what kilometer it extends, what are the order of the layer, all those things you can memorize by listening again and again. Okay.